Okay, this is screencast number 4, take 2. And after listening to your feedback from the first screencast of the incline block, I did make a few adjustments with my equations for solving for acceleration. This is the things that I wanted to know, was force of friction and solving for acceleration. Got my coordinate system set up here and my overall free body diagram. Zoom in a little bit. And we'll first start with the y coordinates. Solving for acceleration here on this side, which is 0, we just get normal force equals the force of weight cosine theta, and the force of weight is just the mass times the gravity. And this is the section that was missing on the previous screencast, was the solving for, so we're substituting in for the kinetic friction with the normal force of friction equaling mu mass gravity cosine theta. And moving over to the x coordinate system, solving for acceleration. Basically divided this equation here, this top equation, by the mass, and then after substituting the force of friction with the mu mass gravity cosine theta, the new equation for acceleration is this, with the masses canceling out. Or basically one step further, for simplifying the equation, I just pulled out the gravity, the negative gravity in here. That is for the incline with friction. And then the decline with friction, as you can see, we're still using Newton's second law for this principle, physical principle. The free body diagram, zoom in a little bit. You can see the arrow still pointing to the center of the earth, which last time it was off at an angle here. Coordinate system set up the same way as I did as far as the incline goes, the positive going up the hill. Nothing's really changed in my y components. Substituting in the kinetic force of friction here with this little bit of information and solving for it, and this is what I'm going to plug it in for the force of friction in the x component, which I'll show you in just a second. So here's solving for the x equation for acceleration. Force of friction minus mass times gravity sine theta equals mass times acceleration. Basically dividing this top part by the mass. And after substituting with the force of friction with this guy, the mu mass gravity cosine theta, we get. And then canceling out the mass from underneath here, and both of these top parts, we get a simplified version, or a much simpler simplified version. Just pulling out the gravity again, leaves with mass cosine, or mu cosine theta minus sine theta, which solves for acceleration with friction.